Welcome back to my channel, and today we're back to talking about science. So this is a continuation in response to Draftscience about the nature of radio waves. So to review, I think that a radio wave is just like a sound wave, which means it has a variable amplitude. And it comes to us because there are particles in the air and they get compressed, and that is how they transmit the signal. Now, Draftscience thinks that radio waves are actually particles. So when we get a signal from a radio transmitter, it's because a bunch of particles are hitting the receiver. Now, one of the predictions you might make on that, and one of the things that Draftscience says, is that the carrier frequency, it can be any shape. I mean, actually, it can't be any shape because it's like throwing rocks against a wall, and you're only going to hear the banging. Okay, there can't be a quiet banging and a loud banging. When the rock hits the wall, it's going to go bang and release its quantum of energy. But so that is the controversy here. And I did show previously in my experiment that you could transmit what looks like a radio wave across, several feet, and using equipment that doesn't look anything like a conventional radio transmitter or receiver. And I was able to show that, you can recover the actual squareness or triangleness of the wave. Okay, so the objection is that, well, that could still be, induction. Basically creating a gigantic transformer, although a transformer that works across nearly a yard is a little bit hard to believe. But what I did is I brought out my vintage Science Fair 101 Electronics project kit. And I had received one of these as a child, and it was the basis of me learning electronics, and now I've pawned that off into a successful software engineering job. But in any case, one of the projects they have here is the 3-transistor AM radio. So the idea is I'm going to create this amplifier so that I can transmit my signal, across like a longer distance, like 2 or 3 rooms away, so that we could kind of eliminate this possibility of it being an induction or a magnetic effect. So I did that, and this radio works. You can turn up the dial, and we can hear some things coming out of the radio there. So this is connected to a very long antenna that's running up my wall here, and it's also connected to a ground wire, which is going to the exterior ground wire there. And I tried to do some experiments to try and receive it. Now the problem is that this receiver section here, it's very difficult to get it actually tuned to whatever frequency I'm transmitting. And so I did some other experiments. I fed the signal generator directly into the input signal here. And what I was able to do is that I was able to transmit an audible signal, like dee, like a tone like that. And I was able to audibly receive it from the speaker here. So the speaker itself would go dee, or I would turn it up and down. I would do that. I can't demonstrate that here because I had to eliminate the noise, because even sitting in a regular house, you get a lot of 60 hertz hum. So I had to turn off my entire house and perform the experiment in darkness. So I can't really show that to you, but you just have to take my word that that's what happened, that I was able to audibly hear the radio signal that I had transmitted from my signal generator setup, which is, remember, that thing here. But instead of seeing it on the oscilloscope, I heard it with my ears. And you could hear a difference between when you're sending a square wave and a triangle wave. So once again, that seemed to confirm that we're sending radio waves and that you can hear the difference. Another thing I tried is that I just directly connected this antenna directly up to the input. This is the input that goes directly to transistors. And you can still hear the dominant radio station. So you don't necessarily need all this tuning stuff in here to actually detect a signal. You can just put it right in, and it will still report the dominant radio signal. So I'm concluding that because of that kind of proves that I must have also been sending a radio signal because I could hear it. So now that may or may not necessarily be true. So there could still be some arguments, but just from reading, how this thing works. See, this is called AM modulation. And what they do is they take the carrier and they modify the amplitude. See, did you hear that? They modify the amplitude. So just the whole concept of AM radio proves that radio signals can and you must be able to change the amplitude, because that is what this circuit is recovering. It's recovering a difference in amplitude. So even though maybe I didn't prove that my transmitter was transmitting a true radio signal, just the whole theory behind AM radio would tend to confirm that when a radio signal is sent, it has a particular amplitude which can be varied up and down. Now I know, draft physics would probably squirm out of that by saying that, well, it's just like a whole bunch of rocks hitting at one time versus a few little rocks. There's all kinds of ways in order to get a different amplitude, I suppose. But my contention is still that radio waves are just like sound waves. They are not, as draft science might say, an actual physical particle going from point A to point B and hitting something, versus a wave, which is just a compression, a local compression of a medium, so that no particle from like the transmitter ever makes it to the receiver. The only thing that makes it there is this pressure wave, versus the idea that there is in fact a particle coming off of the transmitter which travels through space all the way until it hits the receiver. And that's how we receive it. So those are two very different ways of interpreting how radio signals work. And like I said, I don't think it's correct that the transmitter sends off a physical particle which travels, millions of miles to hit a receiver. Much more likely that there's just a compression wave that starts out and that travels millions of miles, and then we get that pressure wave. But that is my opinion. So if you have any comments, please let me know. And if you got this far in this video, I want you guys to do me a favor. I want you to go and below the video, there is the like button. Please click that so that this video gets more likes. That makes it possible so that when people are searching, my video will come up first. All right, that's very important. Another thing I would like you to do is press the subscribe button. Now, people are a little bit confused about what the subscribe button is like. You're going to get junk mail. No, all it is that means that you favorited the channel. It just means favorite. Nothing actually gets sent to you. But if you do want something sent to you, like you want to see my next science video when it comes out, then you have to click the notify button. And if you do that, then you will get a notification when I post something. But otherwise, you will not. So, thanks for watching the video. Please make sure to comment, and hopefully you like this video.